Okay, guys, we'll start the next topic now. Okay, so not too difficult actually. Guys, are you ready? Yeah. So imagine we have this series here: 1 plus 2 plus 4 plus 8 plus 16, etc. And you continue this forever. Then S infinity will equal infinity. You know, you're adding numbers together, the numbers get bigger and bigger. No limit. No limit. We say this diverges. Right? Okay. But take an example like this. If you continue this again infinitely, this time you do get a limit. They don't keep getting bigger and bigger. The total, does anyone know what the total will become? You might be able to visualize the total here. 2, very good. Becomes 2. Okay. It's 1 plus, so this is 1, 1.5, 1.75, 1.825, and so on. Or sorry, 1.875. And this slowly grows to 2. Okay. How can we know if it'll be convergent or divergent? We can actually know from the OR. Here, what does the OR equal? 2. And here, what does the OR equal? A half. So this is our first result. It converges only, no, not bigger than 1, smaller than 1. Okay. Otherwise, it diverges. Okay. So, for example, this is our first example. I'll let you write. You know, wait. You can write this all down in a minute. Suppose I have the sequence 1 plus 6 over 7 plus 36 over 49. This one converges or diverges? Converges. Why? Because the OR equals 6 over 7, which is between -1 and 1. And that's the reason why. Okay, so I'll let you write that down. That's our first example theory. This is in the exam, is only 1 or 2 mark question in the exam. Maybe just 1 mark. Got that?
Yeah.
Got that? Yeah. Can I scroll down? Now, you'll need your calculator for the next example. So the next example, do you remember the name of this type of sequence? Recursive. Okay? And I'll tell you to start with x1 equals 1. So then what does that make x2 equal to? It'll be 1 plus 1 over 2, which is 1.5. Yeah. Okay, what will x3 equal? That'll be 1 plus 1 over 1.5, which is 1.6667, for example. What's x4 equal to? That's 1 plus 1.6, etc. Now, using that trick on the calculator, could you figure out what a limit might be? Maybe it's 1, maybe it's 2, or maybe it's something in between.
1.61.
Yeah, it's not exact, is it? Yeah. It's not exact. So my question now is to find the exact limit. Do you understand? I don't want a decimal, I want the exact limit. That means I want the answer like root 2 or root 3 or whatever. Okay? Let me show you how to do that. Are you looking up, guys? Yeah? So look, here's the trick. This is the trick. Do you think, for example, actually I'll just, you don't need to write the red piece down, okay? The red is just for some ideas. Do you think the difference between x99 and x100 will be big or small? Small. And what about the difference between x1000 and x1001? Yeah, smaller even, I would say. Smaller, right? Because, for example, what was the difference here between x1 and x2? A half. Yeah, 0.5. Whereas the difference here is 0.018. Okay? So if we think about this, as xn moves to x infinity, and as xn plus 1 moves to x infinity plus 1, these two guys, they won't be any different. Because the neighbours, they become very close, right? In fact, these will both be the limit. So here's the trick. What you do is you change this into this. Because what you're saying is, if n is really, really big, infinitely big, then this one and this one will be no different. And they'll both actually be the limit. So if you solve this equation, we can get the answer. Let's solve it. So I'll do it now on the side here for you. X equals 1 plus 1 over x. What should I do to this? Multiply by x. X squared equals x plus 1. X squared minus x minus 1 equals 0. X equals minus b plus or minus square root b squared minus 4ac all over 2a. Ah, there's a problem. We have two answers. But clearly one of the answers is wrong and one is right.
Yes, the minus is wrong.
Minus is wrong because all the numbers here are positive.
Yeah.
So then x must equal 1. So the limit must equal 1 plus root 5 over 2. Now type that in and you'll see it is roughly this. Yep. Okay, so write this down, please. Got that? Now, my next question. Do you think the limit will change or stay the same if we start at a different number? So, for example, if I started, say, at 4, do you think the limit will be the same or different? Yeah, actually, it works out to be the same. It doesn't matter where you start, you'll end up at 1.618 in the end. Okay? Right, next example now. So example 3, let's suppose the formula is given more explicitly. Like let's say xn equals, we'll say 1 plus 2n plus 3n squared over, I don't know, 4 plus 5n plus 6n squared. So what does x1 equal here? Calculate that for me. What's x1? Six over 15, isn't it? 6 over 15, which is 2 over 5, isn't it? Yeah. Now, what about x 100? Roughly 0.5. So we would like to know what is the limit here. Maybe it's 0.5 or maybe it's not. How can we calculate it? Let me show you. So there's a trick here. Here's the trick. What you do, yeah? It's not the same as the last one. Actually, does anyone know the trick here? No? The trick is you divide everything by the biggest n, which in this case is n squared. So 1 divided by n squared, 1 over n squared. The next one, what would that be? 2 over n. Next one? 3. Next one? 5 over n, and then lastly 6. Now you say, what's the point of doing that? Well, watch. As n becomes large, in fact, as it becomes infinitely large, what will this become? Well, yeah, 1 over infinity, what will that be? 0. 1 over a large number is nearly 0. 2 over a large number? 3. 0. 0. 6. Yeah. The limit is exactly 1 over 2. Yeah? Okay. Can you write that down? Yeah. Can I scroll down? Can I scroll down? Yeah. Okay, so example 4. I'll make it my own. 0.12121212, etc. What? So, in this question, what I want to do is figure out what fraction this is. Yeah, what fraction it is. Like, for example, here's an easy one. 1 over 3. Okay, so I want to figure out what fraction this is here. So watch this. What you do is you change this into first 0.12 plus 0.0012 plus 0.000012. And so on and so on and so on. So these here add together to make that. I've just separated it out. Okay? Now, when you look at this, you realize, oh, this is actually a GP. It's a GP where A is equal to 0.12 and OR is equal to 1 over 100. Okay? So what we need to calculate now is S infinity, which we haven't really talked about. So, now I'll go back to this, okay? So just for a moment, I want us to go back to example 1. Just for a moment. So, in this example here that we did, we said it converges. But we never worked out what it converges to. So let's have a look at that now. S infinity will be A 1 minus or power infinity over 1 minus or. Now you might say, well, hang on, what the heck is or power infinity? What's that? It's not in this case. It's 0. Because whenever you have a number which is smaller than 1, and you raise it to a power, it gets smaller, not bigger. For example, 0.5 squared is 0.25. 0.5 cubed is 0.125. So actually, S infinity is quite simply this formula. That's something you'll need to know. That will be 1 over 1 minus 6 over 7, which is 7. Yeah. Now, I think you should add that in, please. And then we'll go back to example 4. What? Am I right?
Yeah. Right.
Okay. Can I scroll down? Yeah? So let's go back to the example I was doing here, number 4. So if I use my S infinity formula, that's equal to A over 1 minus or. So that'll be 0.12 over 1 minus 0.01, which will be 0.12 over 0.99. Which will be 12 over 99. 3 goes into 12 4 times, doesn't it? 4 over 33. So 4 over 33 is the fraction. And you can check it. It does equal 0.121212. There is a second way to do this I want to show you. There's a second way to do it. Do you know the second way? No? Okay. Can I scroll down? Rahman? Yeah. So watch the second way. 0.121212.
Yeah.
Let's call that x. Now, I will multiply both sides by 100. So I get 100x equals, and if I multiply this by 100, what do I get? 12.121212, etc. Now what I'll do is I'll split this into 12 plus 0.121212. Right? However, what is 0.121212? At the very beginning we said that's equal to x. So I get 99x equals 12. So x equals 12 over 99, which is 3 goes in 4 over 33.
Yeah, it's fast.
It is fast. Well, is it faster? Is it?
Yeah.
It's a little faster, maybe. Okay, that's the second way to do this.
Every time times 100.
No. What is the reason I picked 100 here? Sorry, I should have said that. Why 100? Why not 1,000 or 1,000,000? Well, the reason is because it's repeating twice.
So for if it was 0.333 just times 10.
Correct. Right. Let me just give you another one of these ones to try, which I think is kind of interesting. I'll let you try it. You can use either method for my next example, okay? Can I scroll down? Okay, next example here. I have a question for you. I want you to fill in the blank here, okay? So you can either say this, 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 or this. You've got 5 choices. A, B, C, D, E. Oh, I'll give you another choice even. F. Not equal. Okay, so which is the correct one here? 0.9999 ... box 1. A, B, C, D, E, F. What goes in the box? You're going with A. Actually, let's cast a vote then. So, how many people are saying A? 1, 2, 3. You 3? 3 votes for A? Okay. How many people are saying B? 1, 2, 3. You're voting twice. Okay. 4, 5, 6. Okay, fine. C? I can't vote for everything now. 4. D, E, and F. You want to? You're voting for F. Okay, so that's 2. Right. Well, D and E are definitely wrong. Yeah. Well, okay. The answer that best fits in the box here is the C. Okay. Yeah. No, don't. Yeah. Yeah.
Really?
Really. Now watch.
Really?
Watch. X equals 0.99999, etc.
Yes.
Multiply by 10.
Mm.
10x equals 9.99999.
Yes.
10x equals 9 plus 0.99999.
Yes.
10x equals 9 plus x. 9x equals 9. X equals 1. Therefore, 1 equals 0.99999.
But the question is, you cannot reach the limit.
It continues forever.
You
Wow.
cannot reach. Yes, it continues, but you cannot reach. It's not equal.
No, it is equal. 100% it is
You
equal.
cannot reach.
No, it's 100% equal. 100% equal.
Well, that's why I voted for it.
There's no sense.
Let me give you another example.
Oh.
Now, wait. Ming, true or false? True or false? Shh, Ming only.
Oh, this. It's
True or false?
True.
It's true, okay. We're all agreed this is true? True or false?
What was the last thing you
It's the tree. It's the same. Yeah. And this one? True or false? True. Okay.
It's
Now,
a distinct number.
it's the same thing. Okay.
Mm.
Now, A equals B, C equals D. True or false? A plus C equals B plus D. True. Okay. Ming knows where this is going. So, 0, 0, 0. 0. 3, 3, 3. 1/3 plus 1/3 plus 1/3. It's exactly the same. I've given you multiple proofs now.
This guy.
Yeah.
This guy. Hey.
Legend.
Wow. I'm not meant to do this. I'm not meant to do this.
Now, I know.
That's just.
Now, this is important. This is, you know the way you say, for example, like 1/4 is equal to 2/8. Right? They're the same number. You don't say it's nearly the same or it's almost the same. They're exactly the same. Okay. Likewise, 1/2 equals 0.5. Is that nearly the same? No, it's exactly the same. And in the same way, it's difficult maybe to accept, but these two are the same number. In the same way, these are the same number, or these are the same number.
So that means instead of using 1, we can use 0.99.
Yes, you can, correct. Technically, yes. Yes. It's true. It's true. It's true. Just like in the same way, instead of using 0.5, you could even use 0.500.
Yes.
It's the same number. Okay.
But like if you multiply 0.99 by 2.
Yeah.
So give it.
You get your 2. You will get 2.
We'll get to.
You will.
It's 1.9999.
No, because you see, that's not going on.
999 times 2.
What is your calculator saying?
Hey, come on.
It's 2 times.
Because it's the same thing as 1.
A equals B, right?
Yes.
If I multiply both sides by 2, it's still the same,
Mhm.
right? So what happens when I multiply 1 by 2? What do I get? 2. So 2 does equal 0.9909 times 2.
Hey.
It's true. It's true. Yeah. Okay. So this actually does come up in maths again. It's a problem in other. There's theories in maths that work more with numbers, and this does come up as a problem
Understand that we-
in other systems. So often what you'll find later is the way that this is dealt with is you exclude this number. So later you'll see things like, oh, x is any real number except the number 9 repeated. Okay, because it actually does present problems. But it is true though, it is still true. Okay, so homework then which you can start is 1A, 2A, 3A, 4C.
So,
Yeah.
when I was in secondary school, I actually made an equation, right? It's a simultaneous equation. But like, you can get the answer, like you will know the answer, but like a lot of students in my set like couldn't solve it. But
What's
like,
the question?
they know the answer, but like they didn't know how the process on how to solve it.
An intuition, is it?
They don't know simultaneous equation.
They could get the answer, but they didn't know how
yeah,
they
yeah, I
got the
told them the
answer.
answer, but like they couldn't get how to get the answer. Like the solution is what they didn't know how to do. So I can't really remember. Can I just like write it? Like I'm going to write it on my show you.
I'm not sure what you're looking for, but if you have other ways of doing things,
No, I know how to do it.
yeah.
But like, because I'm the one that created it. But I'm saying people couldn't do it.
Do it, try it, sort it.
Yeah, that's fine, son. Yeah, thanks.
Because this sentence is from to the London public transport.
It's from London, is it?
Yeah.
Okay.
Because the London
Okay,
public
you're traveling too much now.